So hello everyone, welcome to another ML projects building series video. Today we're gonna be building a gold price prediction model. So let's start. So here the steps are coming. The step that will gonna be used to build that machine learning model. First, data import is coming. After that, EDA, also known as exploratory data analysis. Here we're gonna explore about this dataset and we're gonna learn a little bit about it. And also we're gonna check is there any null value or is there any issue on the dataset or not. If is there any issue, we need to clean it up. And after that, feature extraction will come. Here we're gonna use some of the feature of this dataset to feed into our machine learning model. After that, also pre-processing is coming. Here pre-processing is not mandatory. If our dataset needs pre-processing or any pre-processing method, then we're gonna use. After that, we can jump into model building process. Using all those steps, I'm gonna get the dataset properly. And using that dataset, what I can do, I can split that dataset into two forms. Also I can divide this dataset properly, and after that I can feed all those data into our ml building process. And after that, we can do a little bit model comparison. Again, this is not mandatory. We're gonna check if we get time, we will use this uh, step. After that, the option is coming is that model building breakdown, model ML model breakdown. Here for ML model, we're gonna be using random forest regression. And this is the diagram for a array for random forest regression. Like here we're gonna use all the decision trees. We are getting up to n number of decision trees. For each of the decision trees, it is getting results. For each of the data set, it will gonna divide. For here it is dividing into two terms, also it is dividing. And for this decision tree also it is dividing, and it is for each of the decision tree it is giving a particular result. And for all of the result that we are getting from all of the decision tree, we're gonna sum it up, and a final result we're gonna get. And using that final result, we're gonna pass that result into our prediction model. So after that, the steps after outcome that we can check. And here as other videos also, as we checked, we can check the steps like measure the r square score, or also we can plot the prediction versus actual price over here. Now the main thing is coming, the ML model that can be used for our regression data set. Like we can also use linear regression, decision tree, KNN, SBM, XGBoost, and GBMS. All those ML model also will gonna work perfectly. But here, as I told, I'm gonna use the RF regression over here, like random forest, and we're gonna predict what our prediction model is giving. So let's jump into our Jupyter notebook. So here are the steps that we're gonna follow to build this machine learning model. First one comes data import. Second one is EDA. Third one with that we saw feature extraction, and after pre-processing and after model building. Pre-processing here is optional. If it is needed, then I will gonna use. And let's right now jump into our Jupyter notebook. So here on Jupyter notebook, what I did, I simply imported all the necessary libraries that we already did on our previous videos also, like NumPy as NP, Pandas and as PD, and here Matplotlib, Plyplot also come as PLT, and Seaborn as SNS. For scalar model selection, we are importing from that library is train, test, and split. And from scalar and assemble, we are importing the random forest regression. And after that, from scalar, we are importing metrics to measure the accuracy of that model that we are building. After that, what I did, I took a data variable, and after that I used a read underscore CSV and gave the data path over here to initialize the data set. And after that, I took the data dot head to visualize the first 5 rows over here of the data set, and all the columns are visible also here. So here mostly 3 4 5 6 columns are there. Each columns has a individual meaning. Let's see. Like for date, we know date is there, and for SPX, it means like S&P 500 index tracking 500 measure of US companies. And after, if we see about GLD, which means gold EFT, a hedge against infection. And of also we saw that the USO also there, like oil EFT, that is measuring for crude oil prices, of course. And also we can see SLV, which means like silver EFT tracking silver prices. And after that we are having all those prices as euro or USD are given over here. So what I can do over now, I can also check data tail over here as we check the data head. So what data tails do, it simply reflects all the last five rows of that data set. Those are the last five rows of a data set. The last row is coming as 2289 index. And what I can check over here, I can go to data shape over here. If we click data shape, sorry, if you click data shape over here, as you can see, like 2290 rows are coming over here and six columns are there. The reason it's showing 2289 over here because Python index starts from 0, not from 1. That's why. So what we can do after that, we can also check data dot info over here. So if we check data.info, like all the information are coming over here, all those columns we saw already, like date came, SPX, GLD, USO, and SLV, and also the prices as euro and USD. And mostly our data types is classified into two terms. One is floating and another one is object form. And total columns are six over here, integer 2290s, which means the rows over here. So what I can do after that, I can simply check is there any null value or not, any null value or not. So for checking the null value, what we can do over here, we can simply call data dot is na function from Python. If we check all those first five and last five rows are coming as false, means for first five and last five there is no null values. If we do a simple sum over here, as you can see, like all are coming as 000, which means there is no null value. If we do another sum, we need to check the total values over here, it is coming as 0. So there is no null value. So what we can do, what we need to do, if we get any null values, we need to simply drop it from our data set and make it clean. And I think there are no null value over here, so it's not needed that operation. So what I can do next, I can go to simple data describe, as data set is clean as I saw. So for data describe, as I can see, the minimum, the maximum value is coming over here, and 25, 55, sorry, 50 and 75% also mean are coming over here. As you can see, the minimum values the euro and USD coming from 1.30 something, and for gold minimum is coming over here 70. It starts from 70 and ends on 184. And also price also difference is maximum value is 1.598, and here the minimum value is 1 point sorry, here is minimum value is 1.030, not 1.30. So there is a major gap on 0.50, over a 0.50 or a little bit more. So what I can do over here, we can check also the main values, the for the price the main value also coming 1.28, and for gold the main value is coming as 122, and counts are there. Counts mostly indicates the rows number. And what you can check, 50% values also there, and 75%. And I think data.describe is done over here, checking all those things. And what I can do over here, I can simply do a data correlation to check how much the data is correlated to each other for each column, which is correlated to which column, we can check over here. So for here I can use that correlation, sorry, I can take a correlation variable over here. And for data we can check all that this function. If we now print this one, I think will work. Okay, sorry. Now if we check over here, all the correlations are coming. The index start from 0 to 1, and also the -1 to 0, like the one indicates the most highest correlated values, and the minus one indicates the most negatively uh, indicated correlation values. And also we have like 0 0.2, 0 0.8. The more numbers are getting towards one, it means like it's positively correlated, and also that column is correlated with that respective column that is coming, and the negative indicates the negatively correlated, which means the opposite. And what I can do over here, I can simply do a SNS heat map over here. So for SNS heat map, we can check like data correlation. If I simply call data dot correlation over here, as you can see, it's coming. I think what I can do over here, I can call not true to see the values, index values over here, like for each of the column, like here as you can see for SPX, what is the relation of GLD gold. Here also it is coming, the diagonal is coming as 111, because for each of the values, like diagonally it is same, because SPX is equal to SPX. Also gold is equal to gold, and also this price is equal to price. As you can see, gold is coming over here. The gold is mostly correlated with the SLV values. Also we saw that is silver pricing values. And as you can see, the silver is, you can check silver over here, it is coming a good correlation with the gold over here. And the most negative correlated, as you can see, it is coming 0.19, which indicates USO values. If we check over here the gold with the USO values, it will be the same as coming as here 0.19, sorry, negative 0.19. So from here it is showing like the light portion, that is 1, indicates the most highly correlated, and for here the most negative it is going, it indicates the negative correlation of that data set. So what I can do over here, I can simply pick only gold from here. So for here, I what I'll do, I'll gonna print, and I took correlation as I defined earlier, and from that correlation, I'll gonna simply call the gold over here. If I call the gold over here, only gold is coming, like all these values. Now what I can do over here, I can simply check it is working or not here, like for data. Okay, it's a single constant, it won't come. Let me define it again. Okay, here all those negative correlated and positive correlated is coming for each of the like columns, as you can see, as we also saw over here. Now what I can do, I can go and check a little bit further about gold, as we are detecting the gold price over here. So what I can do over here, I'll go SNS and go the distribution plot over here. So for this plot, what I can do over here, I'll call the data, and for from that I'll call the gold over here, and from that, as I called the data gold over here, I can choose color, and I can give it as green. If we run over here, as you can see, like it is coming over here, like okay, a little bit mistake over here. So now it is coming, the distribution plot is coming here, on that axis it is coming as density, and the gold is coming over this portion over here. Now as you can see over the density from 120 to maybe 130 or something, 135, it is coming as the highest values. And for lowest values, as you can see, the more it is increasing over here, after 180 it is dropping highestly, and after 60 it is also dropped. And I don't know why, like after 80 or 90 it's suddenly dropped over here drastically, and after that it's also suddenly dropped over here on 150 around, maybe it will be. So like in this plot is, as you can see, like how the price is on the price is moving on this market for the inflection rate or something over the density, as you can see over here. So now after that plot, what I can do over here, we simply learned many things about this data set, that is the process of EDA over here. Now I can go over splitting this data set over here. Sorry. So for splitting the dataset, what I can use over here, I'll take X. For X, what I can do over here, I will take data, and I'll simply gonna drop the gold price over here. Like okay, like let's take another cell over here and call the data, and let's check again what we need to take or what we don't need to take. So for here also we need to drop the data. Date also, date is not needed, also it is in object form, so no use. So what we can do over here, like we need to take columns. For columns I'll use the third bracket over here. So we can take we can drop data, and also we can drop the gold over here. And after the here I will initialize as x is as 1, as we are using the columns over here. So what I can do after that, I will take a y over here, and for y I just need to take the price over here, because I will only be predicting the price, not all other things. So what I can do over here, I will simply take data, and I will take the gold over here. So I think it's running, so let's print it. So let's print x. So for x, as you can see, without this data, sorry, without this date and this gold, it is coming. And for y, as we initialize as gold over here, here the gold is coming, gold inflection rates are coming over here, as we already also told on this data set. Sorry, over here, gold EFT, age against inflection, it is coming over here. So we'll only predict this one, or the y1. So after that, what we can do over here, I'll gonna go to train, test, and split. So for train, test, and split, I'll gonna divide it to 4 terms. X train over L. We also did it on our previous video also. X train, X test, and Y train, and also Y test. For here, what I can do over here, I like previously took this one, like from sklearn dot model selection, I took train test split over here. I'm gonna simply take this one as we initialized previously. I'm gonna simply take this one, and what I can do over here, I'm gonna feed x and y as we initialized these two earlier, dividing this data set. And for test size, how can I pick, like I'll divide it to 0.2. 0.2 means 20%. It will divide 80 to 80 and 20%. We can also take like 90%, 10%, that will come as 0.1. We can also take like 70%, 40%, that will also work. But most of the time the safe position is to get taking 80% and 20% of data. But on machine learning, all those data process, we can like research many things, giving one 0.1, 0.3. After the building process, we can check which one works better. And after that, what I can do, I will pick random state, and for random state I will gonna pick 2. So randomly it will gonna hover the 2 rows, and it will gonna pick. And let's run it over here. Now if I run print x train, I'm gonna check this shape. And also what I can do over here, I can call x test dot shape. So if I run both, as you can see, the shapes are coming over here. Like the columns are same, but the rows are divided into terms, 80% and 20% terms. If we simply change this one and run this one again, as you can see, like it is changed, the test size is changed. Now it came 90%, 10%, but I will keep as a 0.2 over here, as I did previously. After that, what I can do over here, I can start building the model. Sorry. So for the model building purpose, what I can take over here, I simply called the random forest regression, which is a regression model. For the reason, because I took regression model, because as you can see, the gold like that is we are predicting over here, it is coming as continuous value, not classification value. For classification value, we will use the logistic regression, or other also comes the classification like models will come over there. But for now, the regression will come. So what I can do over here, I can simply call the take a regressor over here as a variable, and I'll simply call this random forest regressor, and I want like I'll call and is an estimator over here. For estimation, I'll use the 100. Simply run it over here. So I'll call this regressor again, and I'll use the fit function over here. And after that, what I can do, I can feed x train and y train over here. If we run both, as you can see, our model is going perfectly working over here. No error came. So what I can do over here, I can check data prediction uh, and use the regressor again. And for that, what I can do over here, I'll use the predict function. And if we use predict function, I'll call x test over here. I'll gonna predict. And if we run now the prediction over here, simply check using print. So I'll call data prediction again using print function. If we check the predictions over here, all the predictions are coming. And after that, what we can do also, like we can check the values over here, like actual values or minimum values over here. Also, what we can do right now, we can do a accuracy check over here. So like we can check r square error over here. So for error score, what I can do over here, I will call from matrix. Already I imported the matrix on here, like from scalar, and I imported the matrix over here. I want to simply use that one. So for matrix, what I can do over here, I'm gonna take r square error. Okay, for r2, like it is r square score over here. And what I can do over here, I'll feed the y test. And over the y test, what I can do over here, I can take data prediction. And what I can do over here, I'm gonna simply use print function. And for print function, what I can do, I can use r square, and simply call this one like error 4. If we run it, as you can see, the r square error is coming as percentage, like 98% it is coming, which means also accuracy coming as a 98%, which is a really good thing. Like accuracy is coming really high. So like our model is predicting in a good manner, as you can see over here. Now what I can do relevant to it, I can actually plot a graph or something to see the actual value, and over the actual value the distance of the prediction value. So for that, what I can do over here, I'll take a y test, and for y test I'm gonna list all those y test over here. I am using as a list over here. And after that, we'll take a plot a plot the prediction values over here. So what I can do, I'll simply paste this piece of code here. Already I wrote this piece of code earlier to actually see the prediction values, because if I wrote over here, the time will be waste for nothing. So like okay, like here, okay, I need to use like the data prediction. Before I use test data prediction, it will be data prediction over here. And the for first, let's go from first. So for here, y test is coming for blue and actual values, and for data prediction it is also coming actual value versus prediction value. Let's run it over here. Now it came like actual value versus predicted value over here. So for here, we the blue indicates the actual value and green indicates the predicted value. And as you can see, in between all other all those are a little bit fluctuating over here. Like the most the most value it is coming as a blue over here are the actual values, and for each of the actual values the green values are coming as the predicted values, which is pretty close. And now both line exhibits significantly fluctuations because like indicating violet's price movement over here, like it is fluctuating over the time. And on this axis like the gold price is defined and number of values there. So for using this plot, we can see the prediction over here over the time period for gold price. So up to now, I think it is done to build this model, and our model is also successfully predicting, and we got a good R square error like 98%, around 98%, which is a really good thing. So I think up to today, it is like over right now. So thank you for being such a long time.